answer it. But when we are dealing with only sine and cosine, so we are one step ahead. Good. So this is good. We're okay. Another lovely heart is the angle. This angle. So sine, we learn sine by itself doesn't make sense. Look like 2 plus. 2 plus doesn't make sense on the air. We need to have some angle. All of this 6 trigonometric function, it gets some angle inside. All right. So after looking at sine and cosine here, then this angle of 180 and 270. So those are beautiful as well. Why? Because on the unit circle that you have, so let me bring the unit circle. So you should have this unit circle in exam. I mean, it would be good to have it, or the table. We learned that this 0 degree, this 0 degree, 30 degree, 45, 60, and 90. Those are favorite angles. Those one that we proved, correct? So it's very important. We know it very well. So the other part, so we know them very well. If the angle was 0, 30, 45, 60, 90, we are super happy. Also, if it's 180, 270, and 360, again, those are the coordinates. They are simple. And happens to be 180 degrees, which is great. 180 is, this is 180 degrees, correct? Sine of that is the value of y. But the question said negative. So this negative tells us to go other direction. So we're going to go negative 180 this way. Happens to be same. So the answer is 0. Good, Karen?
Yeah.
So sine of negative 180, this package, the answer is 0. Please do not put sine of 0. Somebody said, oh, 180 is 0, they put 0 there. No, that doesn't make sense. Everything here is 0. So I put 0 on this bracket, you're going to have 0 bracket squared minus. We do the same thing with cosine. Cosine is value of x, negative 270. That means we're going to go this way, negative 270. That's negative 90, negative 180, negative 270. So we're going to be here. Does that make sense? When I go this direction, go 270?
Yeah, because it goes from the bottom to the top.
Yeah, so this is 0 cosine. We're dealing with x value. So I put 0 here. So bracket 0 squared. So we have 0 squared minus 0 squared is, can use a calculator, we get 0. So one thing about this course, the question that you will see is freaking you out. The looks are complicated, but inside is nothing. Same as this, at the beginning, it looks scary. Oh, we have bracket, we have negative, and then we square. But you need to just be calm and so you know it. So you will see a lot of crazy looking questions. Any other question? Mario, question? Have you done your homework? No, go ahead.
No, I'm not done.
I know, but you will have more questions. There are some spicy questions there. So let's see, there's no other question. Let me complete what we were working on Monday. So I'm going to review one more time. Why I'm reviewing, I'm going to draw a circle, sine, cosine, because those are the foundation. I want you to be good at that. So let's start. I cannot believe on Monday I forgot the tangent line. I have to go see a doctor. So this is our unit circle. We have y-axis. We have x-axis. This is x, that's y. Then this direction is plus, the other direction is negative. We go from 0, 90 degrees, 180, and 270, and 360 degrees. Then we learned about a tangent line. Tangent line is a line. This is a tangent line. So this is tangent. X was sine, cosine, and y was sine, correct? For example, if theta is 45 degrees, this point, we made a right triangle. We said this is length of cosine. This is length of sine, which is radical 2/2, radical 2/2, correct? Correct, that's x because the length, this is the value of x and y. For the tangent, we let this line go, it will hit here. This length will be tangent of 45, which is same as 1. If you look at the unit circle, tangent of 45 degrees equal to 1. And if the angle gets bigger to 90 degrees, tangent of 90 degrees will be positive infinity because they're not going to touch. When we say undefined or infinity, that means in infinity they will touch, but nobody knows that where they get touched. But they're going to, but besides infinite, positive infinity. Why do we say positive infinity? Because this is 0, right? Up is positive number, positive big number, and this is negative big number here. Same as tangent line. Here is 0, positive infinity, negative infinity. Can you guys tell me what is tangent of 135 degrees?
-1.
Very good, Joshua. So in order to do this, we're gonna make, so 135 is 90 plus 45. The reference angle is 45. Good, this is 135, 135 degrees. This is a reference angle, which is 45. But if you want to visualize it, if we go this direction, we're never going to touch this line, right? What do? We go the other direction. It goes this way. So that's why this length is -1. Or you can, if you don't, I mean, in here, I'm just gonna, I would like you guys to visualize it. But if I ask you guys what is tangent of 135, you will say this is sine of 135 degrees over cosine of 135 degrees, which is radical 2/2 over negative radical 2/2. It gives you -1. But I want you guys to just visualize it that if it's here, this direction doesn't touch the tangent. So what about tangent of 270 degrees? Karen, what is tangent of 270?
I don't know.
Okay, that's good. So 27, not good, but 270 is here, correct? This is this line is 270. This coordinate is x is 0, y is -1. But again, if you let the line go, they will be parallel to this tangent. But it goes this direction. So it will be negative infinity.
Oh yeah, because I got on the fine. I was Googling.
Please do not get used to. It's good to do research. There's so many resources online on YouTube. They explain much better than me, but it's good to just learn it, take a note, and for the exam, we don't have time to do that. Anyway, but it's good. It's very smart. So we're okay with tangent line, right? Now let's see cotangents. So this was tangents. We have another line here, which is cotangent. So this is cotangent line. Again, only I want you guys to visualize it. There's no, you don't have any question like for visualizing in the exam. For example, for 45 degrees, if this is 45 degrees, if you let it go, if this is 45 degrees, this is x and y for sine and cosine. This much is value 1, which is cotangent of 45. So you will let the line go. If is 10 degrees, correct? If you let the line go, it will cross somewhere big. So this much going to be tangent of 10. So what is tangent of cotangent? Sorry. What is cotangent of 0 degrees?
Positive infinity.
Very good, positive infinity. So it will be parallel to this line. What is cotangent of 180 degrees? 180 is like this. If you let the line go, it goes this direction, and it will be negative infinity. What is cotangent of 90 degrees?
Positive infinity.
Cotangent of 90, this is 90, correct? If this is 50 degree here, 80 degree, okay, 90 degree, it will hit 0.
Oh, got it.
Do you see that?
Yep.
Very good. Yeah. So cotangent of 0 is positive, 180 is negative, opposite of the tangent. But tangent of 0, I don't want to confuse you guys. But that's how we're gonna visualize it.
Professor, I have a question.
Yes.
So when it was cotangent 180, it was negative infinity, right? But it was on the 0 line. But why, when it's like cotangent 90, you put equal to 0 instead of positive infinity?
So for cotangent of 0, correct?
No, the 180. I'm talking about the 180.
180. This is 180, correct?
Mm-hmm.
So if I ask you what is cotangent of 135, for example, if this is 135, you let the line go across here. It will be like -1. If I ask what is cotangent of 140, this going to be that much going to be cotangent of 140, correct?
Mm-hmm.
If I say 150, it will be this much. 179, it will be like this. It goes this direction. If I go this way, I'm never going to touch this line.
Yeah.
So at 180, they will be parallel.
I kind of get it.
You're saying why I don't go this way to be positive?
No, my question was like when we did the cotangent 90-degree, we got 0, right?
Yeah.
But why? Oh, but when we did the cotangent 180, we got -infinity. I thought we were gonna get like 0 too, because like it's on a 0 axis. I don't know if that makes sense.
Okay. Now I know what you. Let's clarify this. This is cotangent, correct?
Yeah.
I guess just 90 degrees and 180 degrees are like opposite signs or something like that.
So look at this is when I make a line, this is a cotangent line. You see that? So this point, this is like a number line. This is 0. So the number line we have 0, 1, 2, 3, -1, -2. So this is exactly the same. So 0 here, then we have 1, then we have 2. Then it's gonna go to positive infinity. Then here we have -1, -2, gonna go to negative infinity. Agree?
Yeah.
So now I'm asking what is cotangent of 60 degree? So this is 60 degrees. In order to find the cotangent, I need to let this line go to touch the cotangent line. So it touched it here. So this much is length of cotangent of 60. Whatever is that. Good. Now if I say what is cotangent of 80, this will be 80 degrees. I let the line go. So this much will be cotangent of 80. So it's smaller than cotangent of 60. Correct?
Yeah. So when I hit like
If
0,
I
it's
go
gonna be
90, so there's no length, it's only 0. There is no distance.
okay.
So this is going to get smaller, smaller, smaller. Now, if I ask you what is cotangent of 120, if this is 120 degrees, I need to let the line go. So this much is cotangent of 120, which is negative. Whatever is that is a negative number. Correct?
Yeah.
So now instead of 120, if I go to 145, if this is 145, so this much going to be cotangent of 145. 170, if I let it go, it will be a lot, correct? It's bigger. If you get 180,
It will
it
never
goes
touch.
this direction.
Okay.
It will be parallel. Where does it touch? At negative infinity.
Got it. Thank
Right? Now, if instead of 60, I go 45, 30, 10 to 0, it goes this direction because I have to cross a double. All right, Nor? Cool. Thanks for the thumbs up. So it's very good to clarify. Again, this is if you know it, you will get easy A in this course. If you have a little shaky here, we will have problem. So now that you know about sine, cosine, tangent, cotangent, now let's have one question that you will have on your exam. So I'm going to go back to this layer. This is your favorite cotangent. This is tangent. That's cotangent. This is cosine, that's sine. We have two more, cosecant and secant. We don't deal with it. And we don't want to, I don't know where is that on this unit circle. When we graph it, you will have a better visualization, but the graphing is the next chapter. So how many quadrants do we have? We learned this is quadrant 1, that's quadrant 2, this is quadrant 3, correct? That's quadrant 4. We go counterclockwise. On quadrant 1, can you tell me true or false? Sine greater than 0 and cosine greater than 0. Is this true?
Yeah.
Correct, yes. So in quadrant 1, which is we are here, any angle here, that means if the theta anywhere, if you be theta, if you make an angle here, the value of sine x and y are positive. So both of them are positive. So it's very important to just know which one is positive, which one is negative on the first quadrant. Okay. What about tangent and cotangents? Are they positive or negative?
Can it be both? Because it goes like two different directions.
Good. Let's see. For example, is 30 degrees. If I go this direction, I'm never going to touch none of them. So I don't go this one. That's not this. We don't go there. We go this direction. So this is positive number because it's above 0. If I let it go, again, this is positive. So any angle here that you make, also tangent and cotangent are positive. All right. So quadrant 1, we have cosine, sine, tangents, and cotangents of any angle between 0 and 90. So between, if theta is between 0 and 90 degrees, all of them will be positive. Good. What about secant and cosecant of theta? If theta is between 0 and 90, are they positive or negative?
Positive.
How do you know?
The table we made.
Very good. Or the relation between the identity. We learn that secant of theta is 1 over cosine of theta, and cosecant of theta is 1 over sine of theta. What does it mean? If cosine is positive, so 1 over positive number is going to be positive. So algebraically, we can see it as well. Or even for tangent and cotangent, because we know sine and cosine are positive, then tangent of theta is sine of theta over cosine of theta. So it's positive over positive will be positive. Same as cotangent. So that's another way to find it. What about in quadrant 2? What do we know about? So quadrant 2, I'm going to say theta is less than 180, greater than 90. That refer to this quadrant. What is sine of cosine? What is sine of sine? Is that cosine positive or negative? Yvette.
Cosine is negative.
Very good. Cosine, and this angle, this is theta is more than 90 and 180, for example. On this quadrant, the value of x is negative, but y is positive. Good, because 0, 0 is here. So cosine is negative and sine is positive. What do we think about tangents of theta and cotangents of theta? Noor, are they positive or negative?
Negative.
Both of them?
Yeah.
This is negative, that's negative. Why is negative? If we let the tangent go this way, this is negative. If we let it go that way, that's negative. Or algebraically, tangent and cotangent are coming from sine and cosine, right? So positive divided by negative or negative divided by positive will be negative. What about secant of theta and cosecant of theta? Jake. Is that you inside of Hoodie or somebody else? Or is Robin Hood?
I think positive.
Secant is secant. So cosecant is positive because cosecant is 1 over sine. Sine is positive, 1 over that is positive. Secant is negative because 1 over cosine. Good. So it's, I mean, probably the way I'm explaining it, I'm making a big deal and you guys confused. But this is easy. You can go to your note sheet, or you can just from sine and cosine, you can x and y. You can easily see that. In quadrant 3, so I'm just going to write it down. In quadrant 3, cosine is negative, also sine is negative. So both of them are negative, negative. So what's going to happen to tangent and cotangent? Tangents and cotangents will be both positive because when you divide them, you get negative divided negative to the positive. And secant and cosecant will be negative because 1 over each. I guess follow me, Mario? Too much negative, positive. All right. What about quadrant 4? So quadrant 4, x is positive. So cosine of theta is positive. Sine of theta is negative because here, this is sine, is negative. Therefore, tangent of theta is negative because we're dividing them. Cotangent of theta is negative. Secant of theta is, secant is 1 over cosine is positive. Cosecant of theta is negative. Any question here? Okay. So this is very important. So now let's go back to identity. cosine of theta, sine of theta. This is our Claude. From here, we have 6 trigonometric function, which is tangent, cotangent theta. So we are defining it. I'm not proving it. I'm saying tangent is sine of theta over cosine of theta, and cotangent is cosine of theta over sine of theta. From here, can we define that tangents of theta equal to 1 over cotangent of theta? Is this true?
No.
No? Very good. Why is no? I mean, they're reciprocal each other. This is sine over cosine, that's cosine over sine. So very good. I mean, Yvette, I think, said no, but you will see a question, not in this exam, but after that. They're saying, prove the identity. So when I say this is equal to that, that means you don't negotiate. You say, okay, this is equal to that, but your job is to prove it. So in order to prove, we have equal sign. You need to just play with one side. You simplify one side. I'm going to keep the tangent of theta and simplify the other side. And hopefully I will get that side. So I have 1 over, instead of the cotangent of theta, this is same as 1 over cosine of theta over sine of theta. 1 over cosine over sine, this is same as sine theta over cosine theta. Sine over cosine theta is tangent of theta. So we proved it. So they are equal. This equal that one. So this is the identity. This is a proved identity. But for now, you should, because I defined this too, so you also have this one in your note sheet. I'm not going to ask you guys to prove it. What about tangent of theta multiplied by cotangent of theta? Elizabeth, is this 0, 1, 2, 3? Which one do you pick? Elizabeth with the calculator.
I'm not sure.
Yeah, we cannot plug in calculator, correct? Because this theta. So here is, we use the identity. Tangent is sine theta over cosine theta. Cotangent is cosine theta over sine theta. If they all cancel, the answer is 1. That's the answer. Good. One more. The biggest identity that you should know is here. Let me prove it for you guys. So if I prove it for you guys, let me erase this. Good. So I'm going to let an angle here. This is theta, correct? And this is radius is 1. I'm going to use a right triangle. This point is x comma y. That means this much is x and this much is y. Agree? Good. So if I apply Pythagorean theorem, what do I get? We get x squared plus y squared equal to 1. Good. What is x on the unit circle? This x is cosine of theta and y is sine of theta. If I replace x and y, sine and cosine, what do we're gonna get cosine square of theta plus sine square of theta equal to 1. This is one of the beautiful formula in trigonometry. That's the first formula. From here, we have 458 million formula coming from this one, infinite formulas. So there are a lot of formulas comes from here, but this is a foundation that sine square and cosine square, if you add them, you get 1. Good. So now let's deal some challenging question. One quiz for you guys. Quiz. What is cosine of 30 degrees?
Root 3/2.
30 degree radical 3/2. Very nice. What is cosine squared of 60 degrees? Oh, sunny.
Is it 1/2 square?
So this is square. This is same as what Karen asked earlier, was bracket and 2 here. But we
1/4.
simplify, put 2. So cosine of 60 is 1/2. Then 1/2 squared is 1/4. Any of you guys solve the extra credit on Instagram?
No.
You guys looked at it? No. Okay. Now, can you tell me what is cosine squared of 10 degrees plus sine square of 10 degrees?
1.
Who was it?
Me.
Yvette? Yeah, Yvette.
Yes.
So 10 degrees, we don't have it here. But there's you need to, we don't want to use a calculator because I'm sure if Elizabeth typed this one in the calculator, not gonna get 1. I'm pretty sure. So for question like this, and they ask you exact, but the angle inside is something which is not listed on the unit circle, that means you need to apply some of the identities. We just learned that cosine square of theta plus sine square of theta, the answer is 1. So if this is theta, that's theta, and the squared is 1. So it's 1. Very good.
Professor,
Yes.
what if they had different numbers? Will it still be 1?
No, I'm not going to ask you guys if different number. If it's different number, it will be different question.
Okay.
Don't stress out for that. Okay. Good question. So now look at the question. Given cosine of theta equal to radical 3/5 and sine of theta is less than 0. Good. Find tangent of theta, cotangent of theta, sine of theta, secant of theta, cosecant of theta. So that was a question I was telling you guys. I give you one and I ask you find the rest of the 5. It will be plus minus radical 22 over 25. For more investigation here. So we have plus minus radical 22 over 25. This is plus minus radical 22 over radical 25, which gives us 25 gives us 5 on denominator, radical 22. We are on this quadrant. We don't get the positive one, we get negative one. So negative radical 22 over 5 is answer. Now everybody said, wow, shoot. So that's algebra.
Quick question.
Yes,
The hypotenuse can never be negative, correct?
very good, yeah.
Okay.
So that's the algebra part. I don't think you guys like to deal with it, but there's another way. When you make a right triangle here, we have cosine of theta. Cosine of theta is adjacent over hypotenuse, correct? So adjacent will be radical 3 and hypotenuse will be 5. If this is theta. Cosine of theta is radical 3 over 5. You use Pythagorean theorem to solve for the y here. If we use Pythagorean theorem, we get radical 3 squared plus y squared equal to 5 squared. We have 3 plus y squared equal to 25. Y squared equal to 25 minus 3 equal to 22. Y will be plus minus radical 22. We are on this quadrant, the y will be negative. So negative radical 22. So this is the way I'm solving for Pythagorean was different. So now we're gonna solve for sine. Sine is right here. Sine of theta is opposite over hypotenuse, correct? So this theta opposite, which is negative root 22 divided by hypotenuse, which is 5. That's what exactly we got. So there are 2 different ways to solve it.
And in the book, it says for sine and cosine, well, same thing as opposite and adjacent, but I think it's easier to visualize. It says sine is y over hypotenuse and cosine is x over hypotenuse.
Yes, yeah.
I think that might be easier for like some people to visualize.
Sure. Yeah, I mean, eventually we're gonna learn that sine of theta equal to y over r. This is r, that's y. Then cosine will be x over r. Okay, so we get to that point. But as Yvette said, yeah, that's another way to say it. I hope I didn't confuse you guys. This is like the core of this course. A lot of algebra, but the good thing is the algebra repeats. I mean, you will see this number most of the time. If you do it, if you have it on your note sheet, how to use Pythagorean theorem, then might theta be here or different quadrant. But if you understand a couple of them very well, you have no problem.
Professor,
Yes.
I have a question. When you were solving for sine and you got like to the fourth step, you did sine squared theta equal 1 and then -3/25. Where did you get the 25?
Here. So I subtract -325 to both sides. I got this one.
Yeah.
Then I find the common denominator, which is 25. So we had 1 minus.
Oh, okay.
Okay, that's the common denominator. We get this one.
And another question. So say that given was like 10 and we're solving for the rest. Does sine and cosine use the same formula?
Yeah. This is what was 10 again?
No, I'm saying like if the given was 10 and like if it's like square root 3/5 and we have to find sine and cosine, they both use that formula, right?
Yeah.
Okay.
Again, there are two different ways. Most people, they like the trigonometry part, the one that make a triangle. I use Pythagorean theorem. So after sine and cosine are done, then tangent, the formula is sine of theta over cosine of theta. All right. So we can just divide them. I'm going to erase some part. So sine of theta is -√22/5 divided radical 3/5. The 5 will cancel. We get -√22/radical 3. Again, I know the radical part bothering you guys, not the trigonometry. This is just dividing, but the division becomes long. And you multiply by radical 3, we get radical 66 divided by 3. All right, so I think it's a good idea to don't have an exam this Friday. Is that okay?
Wait, no exam on Friday?
No.